I'm not recording, and this is some good information. Okay, so when we have our weather systems and they move, do they move from east to west? So they move from North Carolina to California, or do the weather systems usually move from west to east, from California to North Carolina?
California to North Carolina.
Yes, our weather systems move from west to east. Is my camera mirrored? Can y'all read what this says the right way?
Teacher of all.
Okay.
Teacher of all things.
But is it backwards?
No.
Okay, perfect.
No.
All right, well then we're good then. Okay, so yes, our weather patterns move from west to east, and that is because of the prevailing westerlies. Remember that our winds are identified by the direction in which they blow from, not where they're blowing to, but where they're blowing from. And since the winds, do you guys see where I'm pointing at here on the picture? Since the winds in the temperate zone move from west to east, the prevailing westerlies help to move all of our weather patterns across the United States from west to east. That's why they're called the prevailing westerlies. And then the same down here in the equator. It's the prevailing westerlies. They move from the west to the east. And then, of course, our polar easterlies, they blow from the east to the west. So if I were to drop a balloon or float in a balloon, as Professor Sherman did, and I took off from the tip of South America, sorry. If I took off from the tip of South America here, where would I go? Would I start flying to the right, or would I start flying to the left?
The left.
To the left.
Yes, I would start flying to the left. I would start flying to the west because the east, or the trade winds, they blow from the east to the west. So we would start floating westward. So this is why, you know what, I don't have... Did y'all know that Krakatoa is a real place?
Yes.
Yes. I've been wondering that.
It is a real place.
I looked it up on Google Earth.
Yeah. Let me see. Let's see. Krakatoa. It's actually, it could be spelled the way we spell it, T-O-A or T-A-U. Okay. So let's talk about this with the global winds, because this is the type of thinking that I want these questions to do for you guys. Whoa, that's the wrong way. All right. So Krakatoa, we're going to keep zooming out.
Maybe you should put in satellite.
Nope, we're going to keep zooming out this way. So keep in mind that Krakatoa is right here in between these two land masses. It's so small now that we can't see it. Okay, it's getting even smaller. Even smaller. Even smaller. Okay, so that is why when Professor Sherman took off in his hot air balloon from California, the Pacific coast, he blew from the west to the east. Now, I don't really know how he got all the way down here because that means he went this way. But let's check out those global wind patterns. Are those arrows kind of pointing down into the... Let's see. Hold on, somebody's chatting. Matthew, if anything, that's funny, Kaylee. If anything important comes up in chat, can you let me know, please?
Yes.
Thank you. All right. So let me go back to our slide here. All right. So remember, we've got these wind patterns. They're blowing from the east to the west on that part. So that's how he ended up over here, where was it? Right down here somewhere? Near Indonesia, right in between these two masses here. But if we keep thinking about it, remember there's going to be an eruption at some point or another, and I'm assuming that he's going to leave because he showed back up over here off the coast of New York. So he got back on, I'm assuming, a hot air balloon at some point. And since we know which direction the global wind patterns go, they go from where? East to west, west to east. How do we get there?
West to east.
Okay. So, yeah, because he's pretty much right on the equator, right? So he's going to float west to east, west to east, west to east, west to east until if he gets to the top band, then of course it's going to start changing direction. So let's talk about that too. We're going to shift our minds out of Professor Sherman right now, and we're going to talk about what we know as North Carolinians. We're getting ready to start a new season in June. Anybody know what season it is?
It's May.
It's a weather
May.
season.
Summer.
Summer. It's
No.
spring.
No, we're getting ready to go into hurricane season in June. Okay? So,
Oh, snap.
most North Carolinians know what direction that we can expect for hurricanes to travel from. Who remembers where hurricanes are formed at?
Me.
I do.
I know.
Okay?
The ocean.
Okay. All right, so I have heard the correct answer. I'm not sure who it was from. Everybody mute your mics. So I heard the Atlantic Ocean, and then I heard off the coast of Africa. You're both kind of right. So most of our hurricanes come from the coast of Africa, and they begin to build more steam as they move across the Atlantic Ocean. Because remember, the equator is right around down here somewhere. So the waters are very warm. Remember, warm ocean water fuels our hurricanes. It gives them more steam. So the hurricane is formed here. Storm cells are formed off the coast of Africa. They gain strength as they move here. Then what happens is there's a shift in the wind patterns. Do you guys see that everything is moving from east to west off the coast of Africa? So that's what gets the hurricane headed this way. But then we all know as North Carolinians, whoops, sorry guys. What happens when the hurricane gets to Florida?
Everything.
What happens when the hurricane gets to Florida?
It travels up.
Yeah, it starts to go up. Look, do y'all see which direction this red arrow goes?
Yeah.
Doesn't that look like the same, Alex? It's not time for that.
Yeah. And
So what happens is the hurricanes are formed off the coast of Africa. They move across the Atlantic Ocean, and they usually move kind of like this. But when they get to that barrier there, that's when they start to turn. Now, this is not a fixed line. Sometimes it shifts downward, sometimes it shifts upward. But in the general vicinity, usually our westerlies are located here. Sometimes they do shift down, sometimes they do shift up, but it's not like the wind say, oh, we're at 30 degrees latitude, we got to stop. It's not like that. So anyways, when they get to Florida, the westerlies start to pull on the storm system, which makes it curve and go up our coastline. So in perspective of your question from yesterday, you can never tell where the winds will blow you. Do you agree or disagree with this statement after we've talked today? And Riley W., I think you've got the concept, so I want to hear from somebody else. I'm very proud of you. Somebody help me finish my answer. Anybody?
So Aisha has a hand raised.
Okay, so Aisha?
Sorry, that was from the last.
Oh. So nobody can help me answer this question? So that tells me nobody's been paying attention. Do meteorologists know which direction hurricanes are going to go usually?
Yeah.
Kind of. They've got a general idea. Sometimes they don't know how far on land they're going to go or how far in the ocean they're going to stay, but they do know that they're going to form off the coast of Africa and they're going to do a motion like this. It's predictable. It's not exact, but it's somewhat predictable because most all hurricanes follow that same pattern because they're pulled by the global winds. You've got your trade winds that pull it towards the United States, and then your westerlies start to push it back out along the coastline. So, same thing goes with a hot air balloon. It depending on where it's suspended in our atmosphere, in which global wind band it's going to be, that's going to determine whether the hot air balloon is going to float towards the west or whether it's going to float towards the east. Now, if I were floating in a hot air balloon, I would probably, and I were going to leave from North Carolina, I think I would want it to go to the east so that I'm over water, just in case anything happened. I think I would have a greater chance of surviving, maybe, instead of being over land. But who knows? So, Maverick, do you agree or disagree with what Professor Sherman said?
I know that yesterday I put disagree.
Okay, but after our discussion today, so that might be the holdup because I had a lot of people disagreeing, which is why we are having this lesson today.
I say agree.
Okay, so you say agree. Who else thinks that we should agree or disagree with what Professor Sherman says? You can never tell where the winds will blow you. Cadence, can you tell where the winds will blow you based on this global winds map right here?
Maybe.
Sean, can you see my mouse right now?
No.
Okay, well, look at the screen. Can you see where I'm pointing at right now on my screen?
All I see is your face. Like.
Well, I don't know why that is because I'm sharing my screen.
Like above the camera where you switch your mouse is just yellow. Right now it says go to screen share.
Ariana. Right here where my mouse is right now, if I were to take off in a hot air balloon, which direction would I travel? Would I travel to the west or would I travel to the east?
You would travel to the west.
I would travel to the west because that's the way the arrows are pointing, correct?
Yes.
Because we know that our southeast trade winds go that way. Let's see. Maya, if I were to take off in a hot air balloon from right here in Europe, which direction would I travel? Would I travel to the east or would I travel to the west?
East.
I would travel to the east because that's the direction that the arrows are going, right? Because our prevailing westerlies blow from the west towards the east. So anything that's suspended in the atmosphere is going to go to the east. Very good. So I just gave you two different scenarios, and you were able to correctly tell me where the winds would blow me. So, using what your classmates just said, do you agree or disagree with what Professor Sherman says? You can never.
I agree.
You agree that you can never tell where the winds will blow you?
Oh, no. No.
Okay. So your answer, Maverick, you were correct, should be that I disagree with what Professor Sherman said because I know that global wind patterns will determine which direction the balloon will blow. And if you wanted to go above and beyond and give a really stellar response, you could say, for example, the westerlies, because that's the weather system that's most important to us, or that's the wind system that's most important to us, because that controls which direction all of our weather systems flow. For example, the westerlies blow from west to east. All right. So today, it's 9:30. All right. So today, we're going to talk about the balloon elevating and de-elevating, whatever the opposite of elevating is, in your response. Now, we know that Professor Sherman threw things overboard to make the balloon go higher. That probably wasn't the best practice because he's polluting the earth. He's probably getting rid of things that he needs. Not the best practice. So we're going to be good scientists here, and we're going to think about things. It is very important that you guys watch the density video to remind you about how, please remember to keep your mic muted when I'm talking. If you've got a question, you raise your hand, and then I'll call on you just as soon as I can. Okay, so remember, I need you guys to watch the density video so that you can remind yourself of what molecules do when they get cold and when they get warmer. And I don't want to give too much away. So I'm going to stop there. I'm just going to remind you to watch the video after you listen to the story. I've got a lot of people not listening to the story. I broke the chapters in half. Okay? So please listen to the story. This half is not very long. It's the funner half of chapter 8. Because if you remember yesterday, they were getting ready to get onto the airy go-round. So now you get to see how that ended up for them. Very interesting, by the way. So you don't want to miss it. And if you missed it yesterday, you might want to go back and read the chapter. So it says that they continue to let hydrogen gas out of the balloons to keep the boats at the same level or to lower the boats. So using what we've learned about gases and the density of substances, what is another way the children could have got the boats at the same level? So remember, when you answer your question, the first thing you're going to do is you're going to restate the question in your answer. One way the children could have got the boats at the same level would have been blah, 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 blah. Whatever you guys come up with after watching the density video. Your response has to be related to density. Your response, because like yesterday, I got one that was not related to science at all. Because the response that I got yesterday was, I agree with Professor Sherman because you never know what life is going to give you. That has nothing to do with science. That has nothing to do with the winds. That has nothing to do with balloons. That has to do with some good life advice, but that is not at all showing me what you know about science or what you know about the story. So make sure that your answer is about the density of gases. What is a way that they could change the density of the gases in the balloons so that they would lower to all be at the same level? Okay? Any questions? All right. If y'all don't have any questions, you may skedaddle. If I called your name earlier, I need you on Lexia until family time. Love ya.
Miss Hernandez,
Yes.
do we have math today?
Yeah. Well, I don't know. It depends on if you finished your stuff from yesterday. If you did the Kahoot and the other thing yesterday, then I don't believe you do. I think you're good.
Okay.
And I'm finished with everything.
You already answered your question for today too?
Yeah,
Okay.
I did. I could go back and recheck it though.
Okay. Well, I will try to give you some feedback before it gets too late, okay? That way, if you want to go back and revise your answers, you can.
Okay.
All right, love. Have a good day.
Archer, get off the counter.
I love you.
Miss Hernandez.
Yes, PJ. Oh, my gosh, PJ. I have missed you so much.
No.
I have missed you. How are you?
I'm okay.
All right. Well, that's good. What's up?
I got two things to tell you. I got
Okay.
my haircut.
You got what?
My haircut.
What? Where'd you get your hair cut at?
My aunt.
Oh, your aunt. I was getting ready to say, Bash and Seth, they've been waiting for a barbershop to open. They're ready for a haircut. I won't let them cut it yet because I said we're doing the quarantine challenge. I love you, Bash. Hey, your shirt's on backwards. Oh, I want to see your haircut.
No.
No? Can I Zoom with you later and you show it to me? Oh, it looks good.
No.
Whatever. You're so silly.
And there's a hurricane starting to form.
I love you, Bash.
There's a hurricane.
I know. I saw it. There's a tropical depression, and it's forming out off of storm cell that formed off the coast of Africa. And right now, it's in the middle of the Atlantic Ocean. It's so crazy how things work out. Hopefully, it doesn't turn into a hurricane, though. Hopefully, the waters are still too cold.
I hope it does.
A hurricane in May?
Yeah, that would be nice.
Can you imagine if hurricane season started in May? Oh, that would be horrible.
What if it started in December?
That would not even be possible. Is that it over there? No, I think that one's mine. No.
It would for Florida.
Bye, Miss Hernandez.
Bye, PJ.
It would be possible for Florida.
What would be possible for Florida?
Having a hurricane in December.
Maybe, but I think the waters are still too cold. Just in general for Florida. Even though the waters are much warmer in Florida than they are here, the waters have to be pretty warm to fuel a hurricane. That's why they're talking about this one so much, because if the hurricane forms right now in May, that could be bad news for hurricane season, because that means that the waters are already warm enough to produce a hurricane. I love you, Seth. Have a good day, okay? I'll see you in a little bit. In an hour? No, I'm going to pick you up earlier today. Oh, no, earlier than that. Maybe like 4. I'll call. When you're ready, sorry, guys. All right. So, guys, I think since the boys are going and hanging out with their dad today, I actually think I'm going to close up my computer and I'm going to try to get to Miss McLean's house before we have family time. Okay? Riley Bird, if you need my help, you and I, just send me an email later and I will get up with you when you finish your math group today with Miss Hernandez.
Okay.
Okay? All right. Y'all have a good rest of your day. Happy birthday, Kaylee.
When am I getting my shirt?
They're going in the mail today. So maybe Saturday. It might be Monday, but they're coming.
Okay, goodbye.
Yeah. Is it his proofs? All right. Bye, guys.
Bye.
Oh, do you have this shirt at your house?